Hope everyone went through the lecture till third week, or we can say fourth week also. Okay, so this shall we start? Okay.
Yes.
So this is the third week for live session. In the first week, it went that intro part, and second week some distribution and starting intro of that test, a different type of test that is done in statistics. Okay, and in the continuation of the last class, we have spoken about some tests like t-test, f-test, and then chi-square test. It is all tests, so we will do some problem based upon the test. So our focus will be based upon mainly on t-test and f-test, and in the last we'll discuss ANOVA. That is the third week module. Okay. One more thing I want to clarify. Like for assignment, whatever the queries you have, you can ask in the discussion forum will be there. We are here to solve your doubt, like some based upon the concept, and then we'll solve some that example problem. Okay. So can anyone tell, like when we are speaking about the test, what do you mean from that? Can anyone? When we are saying like we want to do some testing in that statistic, what do you mean actually? Anyone, please? Is it my voice audible, na? Hello? Anyone, please respond. Okay.
Yes, sir, audible.
Okay, okay. Yeah, when we are speaking about the test, so when we say the significance, so we will say, okay, we want to see that whether between the data any changes are there or not, or if we are what we are assuming whether any change is there or not. Okay. So in terms of quantitatively, we want to check how much changes are coming, or either whatever the hypothesis we are choosing. Like we want to check whether if we have administered any drug. So before and after administering the drug, is there any change or not? Is it getting increased, or either it getting decreased, or either it is same? So there is some sort of procedure are there to follow up when we are saying about this what we can say test. So first one is that we have to check with that what is the sample size or either population size. Based upon that, you have to choose for the go for the testing. We have different types of test. We have t test, we have f test. Is it correct?
Yes, sir.
And we have some chi-square test is also there. We have that f test is also there. If we speak about the small sample size, if we speak about the small sample size, so we have to go for the, when we will say small sample size, so we can go for the t test and then chi-square test and then f test. If someone is saying that they want to check for the good fitness test, like fitness like a fitting of the data, so they can go for the chi-square test. Okay. And then after if you say ANOVA, so ANOVA it's again another test, like it's an analysis of the variance. You all went through the lecture, na? Okay, so we'll start the session now. We'll start today's session by t-test, because I have told whenever we'll say test, so you have to first you have to outline the what is the procedure in the test. Let's say in the test first you have to set the hypothesis. Hypothesis. What is that hypothesis? Can anyone? Hypothesis is a, we can say we are putting assumption, or either if we are
We have to
giving.
putting a null hypothesis. I mean, initially we have to make a assumption. Generally, it is opposite to the what we have to prove, and there will be an alternative hypothesis.
Based upon the
Then
question, like they have asked whether it is both are same or not, or either it is getting increased or decreased, so that will be your alternative hypothesis. Is it
yes,
correct?
sir. Yes, sir.
So then after once you have decided for the that hypothesis, you have to go for the statistic, like a test statistic. For different type of test statistic, their formula will be different. Okay, once you have calculated the test statistic, then you have to see whether whatever we have calculated t value, if we are going to t-test, so we'll calculate from the formula, like a statistic formula, we'll calculate the some t value. Then we have to see, okay, we have calculated based upon the we have calculated. Then after we have to based upon the level of significance and degree of freedom, we have to check from the table. If the table values are less more, and then calculated values are less, so we have to accept the hypothesis. Is it correct? Null hypothesis.
Sir, can I ask one question, sir, here?
Yeah, sure.
Actually, the concept of degree of freedom is not clear for me. Can you explain in just in nutshell?
Yeah, sure, I'll explain. Whenever we are speaking about the degree of freedom, just 1 minute.
Hello.
Hmm? I have lecture. I'll call you later. Huh? Yeah, degree of freedom in statistic will say like that number of sample of data. Based upon that, how let's say when we are saying degree of freedom, so when we like in mechanical we'll say, so if we are saying 3 degrees of freedom, so they are going to move in x, y, and z direction. Okay, so this is in terms of mechanical. If we say in the statistic, so we have that number of sample. Let's say we have somewhere around 30. Okay, so for the some test we have to go one less than that, so that we can go. We can our testing we can do up to that level. Like it's a degree of freedom that our sample is going to include up to that level. Is it correct? Like it's a like we are taking. We know the sample. Okay, we know the sample, but we are checking, okay, 1 minus 1 we are taking just for sake of like our factor of safety, we can say, so that they are going to include all the data. Is it correct, or is it clear?
Uh, can you explain? I mean, sir, the degree of freedom means the total number of sample minus one. You are
Yeah.
telling.
Ha.
Means like standard deviation in the formula for sample population we use in the denominator
Yeah.
n minus one, like that.
Yeah.
Means up to that level we can include.
Yeah, it's like if we are taking as a factor of safety that that cannot be that much. They have taken this much. Okay.
Okay, sir. Okay, sir.
So we have to calculate based upon the degree of freedom and then level of significance. We will go for the tabular value. Then we will see whether if tabular values are greater than. So we have to accept the null hypothesis. Is it correct?
Yes, sir. Yes.
and if the calculated table, calculated t value or either calculated statistic value will come greater, so means we have to reject the hypothesis. Okay, so we will start with this one sample t-test. Okay, so in t-test we have somewhere some 4 types of problem. The first one is that when we speak about the t-test, so we have some, what we can say, uh, conditions for that. For t-test, what is the conditions? Like population is, first we'll speak about the conditions. What is that? Anyone can?
It should be normally distributed.
Okay. Population is
Sample
infinite.
size is less than 30.
Yeah.
Small
Infinite,
size population.
normal. Okay. Then sample size should be small. Like n less than 30. Then population variance is unknown. Okay, then one more thing, like that alternative hypothesis should be one-sided. Maybe that will be the right hand or not should be, it like a maybe. Either it can be left tailed or right tailed. Okay, so if you say like first case will be in that t-test will be having 4 types. First one will be to test the significance of the mean of a random sample. It's like a single mean. If we go second type, so to test the significance of the difference of the mean of a 2 sample. Here it was only one mean was there. Okay. Then second case will be the to test the significance of the difference mean of a 2 sample. Okay. We will do some problem based upon that. Third case will be to test the significance of a difference between the two mean sample. Then means dependent one. This was one that independent. This one is dependent. Then we'll go the last type to test the significance of observed correlation coefficient. So this is all about the t-test. It's like we have some four type of that problem will be there. Then we will go for the f-test and we will do some problem based upon that. Then after we will go with the ANOVA. Okay. So if we say about that t-test, so first we are going to decide the hypothesis. I will take one slides. Just 1 minute. So what is the first type 1? What is that? To test mean of random sample. What is the first case? Set the hypothesis. Okay, but what do you mean? H0 we have to fix x bar is equal to mu. Then what is the alternative hypothesis? Will be h1 either that can be a two-way. It mu, it's like a two-tail, or if you are saying f greater than mu, so that is the right-tailed. If you are saying s less than, so that will be the left tail. Okay, then after second step will be, this is the steps we are saying, this is the steps. Whenever you see any problem, so you have to start with the hypothesis. Based upon that, if in the question they have told like whether we have to check whether that is getting increased or not, or maybe any differences are there or not, so it will be two tail. They told, okay, after the administering drug, check whether the drug effectiveness got increased. So that means that we have to go for the one tail test. Then second case will be the test statistic. So for t test, it will be t barabar x bar minus mu upon sigma x. So this will be the standard deviation for the sample. For simple mean, so what will be the t is equal to x bar minus mu upon s upon root under n. Okay. That is the s, this is root n. Okay, so this is n is equal to number of sample. If we say I'll take one more page. Okay, and degree of freedom nu is equal to n minus 1, where x bar is equal to, what is the sample mean? Okay, mu is equal to population mean, then n is equal to sample size, s is equal to sample standard deviation. Their formula is root under x minus x bar whole square upon n minus 1. Okay, so this is the second step. Now once you put this s in this x bar minus mu upon s up into root under n, so you will get some t value. So this will be your t calculated. Okay, then after third step will be decision. Okay, for given level of significance, so we have to calculate, maybe that can be a alpha is equal to 5%, 10%. Okay, so at a certain degree of freedom, that degree of freedom is n minus 1, we have to check with the table. Okay, if calculated t greater than tabulated t, so we have to reject the null hypothesis. Is it correct? And then after you have to check with the calculated t less than of tabulated t, so means you have to H naught you have to accept, means there is no significance. Any doubt is there till here? Anyone? Any doubt is there till here?
No, no, sir.
Okay. Will solve based upon the question based upon this, or shall I explain one more time? The first test is that to test the mean of the checking the significance of the mean of the random sample. Okay. So what is the first step? You have to define the hypothesis. And null hypothesis will be means there is no significance difference. Okay. Then alternative will be based upon the question they have given. Then after you have to calculate the that is the statistic. T is equal to x bar minus mu upon sigma x. That is always same for all, but sigma x value will going to change for different types of test. So for simple mean of random sample, this is the formula s by root n. Then for s we have that formula also. Sample standard deviation also we have the formula. Root under x minus x bar square whole square by n upon n minus 1. Then degree of freedom will be n minus 1. Then after once you have calculated the t calculated, so then you will check the for given level of significance and degree of freedom. You can check, you can get the value of t tabulated. Then after you have to see if the calculated t is greater than the tabulated t. So you have to reject the null hypothesis. And in the second case, it like means other case will be the calculated t is the less than of the tabulated t, means we are going to accept the null hypothesis. Okay. So we will do the question. I will give you some 5 minutes. Please, can you do it? Meanwhile, I'll wait for. What is the question? Like 10 individuals are chosen at random from a population and their height are found to be inches 63, like they have taken some 10 samples are there. Discuss the proposal that the mean height in the universe is 65 inch. Please do it. I'll wait for some 5 minutes and then we'll start. What is the mean height is given? Okay. Anyone is trying this one? If anyone have solved, please let me know the answer. Shall I start?
Sir, wait.
Okay.
Sir, can you please show the question?
Yeah, sure.
Because I want to see. Sir, answer is not significant. We can't reject the null hypothesis.
Okay. I'll check. Huh? What is that? We have to check with the null hypothesis. What is that? We have to assume mu is equal to 65. Means that mean height in the university is 65 inch. Okay. What is the alternative? That we have told it is 65. So other will be mu is not equal to 65. It means this is the two-tailed test. Is it correct?
Yes, sir.
Now we have the data set. What is the data set? We'll go next. I'll take one more slides. We have the data set x. Then we can calculate x minus x bar. Then we can calculate x minus x bar whole square. What is the first one? 63, 63, 64, 65, 66, 69, 69, 70, 70, 71. That is correct, no?
Yes, sir.
So first we can calculate the x bar. How we can calculate? Sigma x upon n. How much that came? Can anyone tell?
It is 67.
Okay, 63 plus 63 plus 64, then 71 by total we have 10. It came 67. So what is that is the x minus x bar. 63 minus 67. What is that? Minus 4. Minus 4. Minus 3. Minus 2. Minus 1. 2. 2. 3. 3. 4. Okay. 16. 16. 9. 4. 1. 4. 4. 9. 9. 16. Okay. So now we can calculate sigma x minus x square. How much it will come? Can anyone tell? 16, 16, 32, 32, 9, 41, 44, 41 plus 4, 45, 6, 46, 50, 54, 63, 63, 9, 72, 72 plus 16. Is it 88? Is
Yes,
it
sir.
correct?
Yes,
Okay.
sir.
Is it correct? So now we will calculate the sample standard deviation. What is the S1? Yes. What is the formula for that single mean? X minus x square upon n minus 1. 88 minus 10 minus 1. 9. How much it came? 3.126.
1, 2.
Okay. So now we can calculate the T. T calculated. What is the formula? X minus x bar minus mu upon S. What is the x bar? 67, 65. What is the S? 3.126 into n will be the 10. Can anyone say what is the value? 2.02.
2.02.
Now we'll calculate the degree of freedom. N minus 1. What is that?
9.
10 minus 1.
9.
9. Now, as there is no level significance is given, so we'll go for the level of significance 5%. So T at 9 degree of freedom 0.05. What is the value? We'll check.
2.262.
Okay. Shall I show the table, or everyone is able to get it now?
Yes.
Okay. I will just write. So it's a 2.262. So T calculated is less than of T tabulated. Means we have to accept null hypothesis. Is it correct now? Yeah, that's the same way you got also. Means mean height of universe is 65. Anyone have the any doubt till now? Okay, we'll go ahead with the next question. Can anyone read this question? This is the direct one. A shop manufacturing company distributes a particular type of brand through a large number of retail shops. Before a healthy advertising campaign, the mean sales per week per shop was 140 dozen. After the campaign, sample of 26 of was taken and mean sale were found to be 147 dozen with standard deviation 16. Can you consider the advertisement effective? Just 1 minute. That's it. Please try this question also.
Sir, here population mean is 140.
No, it's a
Sample mean is given.
sample. It's a 26 number. It's a less than 30 only, no? Because it's a mean. They are saying they are going to find out. They are going to increase or decrease. That's a mean, not the sample. Sample is still 26.
I said population mean is 140.
Okay, okay.
And sample n is 26, and
Yeah,
this
yeah,
is sample mean, that is 147.
yeah,
And the sample standard deviation is 16.
yeah,
This has been given, and then we have to just put the figures and find out the t.
yeah. Please find out what is the answer they are getting. What is the given standard? N is equal to 26. This is the sample. Mu is equal to 140. Once that advertisement happens, so it becomes x bar. So it's become 147. Standard deviation is 16. So now we have direct formula. You can just put it there. So start with the set the hypothesis. What is that? We can take H naught is equal to advertisement is not effective. What do you mean?
Significant. We can reject the null hypothesis.
Okay. So we will say H naught is equal to B is equal to 140 dozen. What is the alternative hypothesis? Like they are asking to that is the advertisement is effective, means their mean should increase. H1 should increase greater than 140 means advertisement is effective. This one you understood, na? Like before the campaign, like let's say we have one company. I was not doing any campaign for the advertising. The sale was 140 dozen, but now when we have put the advertisement, so like it went to the 147. It means that our the whatever mean was there, that is going to be like what we are told, like that advertisement in the null hypothesis that is not effective, means it was 140. So that they are checking, they are asking to check whether the advertisement is effective or not. Okay, so this is the one tail test. One tail. Which one? Right tail. Just because of similarity, it will come same for both.
Sir, here you wrote in the first line advertisement is not effective, and then mu is 140 dozen. Null hypothesis is not effective.
What? I didn't get you.
Means what is the null hypothesis? The advertising is not effective. That is null hypothesis.
Uh-huh.
But if you wrote there advertising is effective. That's
No, just see. I want to check whether that advertisement is effective or not. So first we will check whether we will check. Okay, I will consider that my advertisement is not effective. So that is our assumption. Sometimes we will go in a positive view also. Let's say I will say like last question, what was that? Universal height stairs mean is 65. So we have assumed. Okay now. But here what? Just because of we are going for the positive, what is the effect coming in the positive? So first we have to assume the negative. That will be the correct. So that will be your assumption. If
means mu is equal to 140. That is null hypothesis. Means it's not effective. Advertising is not effective.
yeah. So now we have defined the null hypothesis. Okay. So we will calculate the degree of freedom. N minus 1, it will be the 26 minus. Can anyone say what is the answer for this final one?
Answer T is 2.22.
Like whether advertisement is effective or not in this term. I will do. T is equal to x bar minus mu upon s into root under n. What is the x bar? 147, 140. What is the s? And this is the 26. Can anyone say what is the value of that? 7 by 16 into 26. How much came? Anyone please? This value. I'll calculate.
T is 2.22. 2.22.
2.22. Na? Okay. So there we will consider level of significance 5%. So we will check with the T tabular for 25 degree of freedom and 0.05. Can anyone share this value? I will see. I have the table. This is the one tail test, 5%, 25. It should come 1.706. Is it correct? 708. Otherwise, I'll show you if you are not able to get it. This is that. We have degree of freedom of how much? 25. This is 25 for one tail test, 5% level of significance. So first column, like second column, like in this the first column, then it will go 25. So it will come 1.708. 1.708 is correct now?
Yes, sir. 1.708.
Yes, sir.
1.708. But we got T calculated is greater than T tabular. But we'll take the decision. We have to reject the null. Is it correct now? Reject the null hypothesis. So means finally the advertisement is effective. Any doubt is there in this question? I'll move ahead. Any doubt is the type 1 t-test? Please, anyone respond.
Okay, sir.
No, sir.
Okay, we'll go ahead.
No, sir.
Then we'll go with the to test the significance of the difference mean of a two sample. Like let's say we have a population 1, like a population 1 here, and second population is there again. Okay, so for that we will be having mu, then it will come like x1. Let's say for this we have mu2, it will come x2. So again that n1 again less than 30, or either combined should be less than 30, it should be. Okay, n1 plus n2 it should be less than 30 only itself. Okay, and for this case we have assumption sigma 1 square is equal to sigma square, like variance will be equal for both populations. Okay, so where we have to start, that will be steps I will say. Set the hypothesis. Null hypothesis, what will be there? Mu1 is equal to mu2. Okay, go to the next slide. I am writing on that PPT itself. Why? Because I can take the any book PDF and then I could have explained to you. Just because of that, it will be easy to understand when I will write on the board itself, instead of that showing to the PDF and then I'll solve that equation. Okay, is it correct, or shall I send that show you to that PDF itself?
So this is better.
Okay, fine. That's what I feel. This seems to be better than the showing the PDF, so that's why I'm going ahead with this. Okay. So, what is the alternative hypothesis? Will be for one population, it will be not same. So, for it will be the two-tail test. Okay. Then for one tail, it will be either greater than or less than. Okay, then after second case you have to go with the test statistic. All things will be same, only the formula for the test statistic will change in the different case. For this case, t is equal to x bar for 1 2, then we are going to be x. So instead of that one that we have the formula x bar minus mu, so now it becomes x bar 1 minus x bar 2. Then finally it will become t is equal to x bar minus x, then s root under 1 by n1 plus 1 by n2. This formula, this is the main thing. You have to say, okay, they have given two population, so you have to apply this formula. So now we can simplify x1 by minus x2 bar s n1 n2 plus n1 plus s. Just I have simplified, nothing I have. If s already given, so there is no issue with that. So now we can calculate the S also. What is that? Sigma x1 minus x1 bar whole square plus sigma x2 bar. Same formula, nothing new is there. In that n1 plus n2 minus 2. Okay. Then after we can calculate the degree of freedom also. That will mu is equal to n1 plus n2 minus 1. This is your
So can we remember directly the last formula?
yeah. You can remember. If they
Okay.
have given that sample like and if they have given directly a standard deviation, so no need to remember. You can apply directly here. Number of sample is
Okay.
given, so you can just simplify. You can put the standard deviation and put this value, you will get the answer. If standard deviation is not given, so you can apply this formula.
So the standard deviation formula in the denominator is N1 plus N2 minus 2 or minus 1.
It will be minus 2.
The degree of freedom you have written n1 plus n2 minus 1.
1.
No, sorry, it's 2.
Uh-huh.
Okay.
Because they have 2 samples, so they have to be taken with 1, 2. Then after you have to go with the decision. Same. The third step will be at certain degree of freedom and level of significance, you have to consider T degree of freedom, comma, the level of significance. You will get a T calculated. Earlier you got T, no, this is T tabulated, sorry. Now, if T tabulated greater than T calculated, so we have to accept the null hypothesis. Null hypothesis. And if T calculated greater than T tabulated, so we have to reject the. So we go. We'll do one question based upon this. Please do it. Below are the given gains in the weight of pig fats on two diets, A and B. Okay. So whether they are saying, you can check the significance whether uh, which which diet is the effective, diet A or diet B. The question is saying, I forgot to add the last line. Test if two diet differs significantly as regard their effect on increase in weight. It's like a two diets are given for the pig fats, and they are saying whether there is an increase in the weight or not. So please just go ahead with that. So what is the solution? Start with the like n1. If we count, how much is that? 1 2 3 4 5 6 7 8 9 10 11 12. N2 12, 13, 14, 15, 15. Overall, how much came? Less than 30 only. Start with the setting the what is that? Can anyone tell like how we can define the null hypothesis here?
X1 is equal to
Null
X2.
hypothesis both are same. And that A and that is same. And alternative can be not same. It's two-tailed test. It's not
Sorry, your voice is not that much audible. Like it's not clear.
means in null hypothesis we can say that both the diets are not same.
No, either we can say there is no significant difference. Means their both mean will be the same.
Null hypothesis will be the same.
Yeah.
It's not significant, and alternate hypothesis can be significant.
Yeah, we can say there is no significance difference between the mean increase in weight due to different diet. Shall we write like this? X1 bar is equal to X2 bar. Shall we write like this? Is it correct now?
Yes, sir.
Yes, sir.
Now we will go for the alternative hypothesis. Now we will start with the alternative hypothesis. What will be there? X1, their mean is not going to be same. Which test? This is the two-tailed test. Correct now?
Yes, sir. It will be
Now we have a two different set of data. So first we will calculate x1 bar. So we will calculate sigma x1 by n1. Please tell me this value. Okay, then after we can make two tables. X minus bar. Second will make for x1 minus x. This is for 1. Like for diet A. For diet B will be the x2 and then x2 minus x2 bar x2 by x2 bar whole square.
so if you use Excel, that will be easy to calculate.
Yeah, we can use. No issue with that. I know some other software like what you can say Origin and then MATLAB. I know I can solve, but Excel I'm not too much frequent. If you are too good, so you can use it. Otherwise, this is I will just show you like how it will look like. So you will be able to better. You will able to understand now. What is the data set? 25, 32, 30, 34, 24, 14. Please others like you try to solve what is that answer we are getting in the last, whether that which diet is more effective, just tell. Okay, 32, and 24, 30, 31, 35, 25. Calculate sigma x. It will come somewhere 336. Is it correct now?
Yes, sir.
And 336 by 12, it will come somewhere 28.
28.
And second data set we have 44, 34, 22, 10, 47, 31, 40, 30, 32, 35, 18, 21, 35, 39, 22. How much it will give? Sigma x is equal to 450. Is it correct? Then we'll start with this one. -3, -4, not -4, it will +4. 2, 6, -4, -14, 4, -4, 2, 7, 30, 31, 2 to 3, 7, -3. We'll start with the 9, 49, 9, 4, 16, 16, 196, 16, 36, 4, 16. Maybe from next class I will, this slide I'll make earlier itself, so that we will not able to waste time creating. So let's give it directly. Okay, I'll do it. 14, 4, and then minus 4, -8, -20, 17, 1, this is 10, 0, 2, 5, -12, -9, 5, 9, -8, 64, 81, 25, 81, 144, 144, 10. How much that? 25, 4, 0, 100, 1, 17, 17, 289, 400, 64, 16, 196. How much came? It's calculable. 140, 10 no? Is it correct? I'll go ahead with that. I will solve. Now we will go with the S. What is the formula? x1 minus x1 bar square plus x2 minus x2 bar square n1 plus n2 minus 2. What the first one came? summation 380 plus 1410 by 25. Can anyone tell this value? Root under 380 plus 1410 by 25, 71.6.
8.46.
8.46. So now we got P value, S value. We will calculate the degree of freedom also. So N1 plus N2 minus 2, it becomes how much? 25. Now we will calculate the T in mod. Anyway, that value will be always positive, even though that the value is coming negative. So we have to take in the positive value. What is the formula? X1 bar minus X2 bar into S, N1, N2 first one is the we take 28 minus 30, 8.46, 12 into 15 by 12 plus 15 minus 2, 8.46, 15, 12, 180 बट can anyone tell this value? Minus point 61. So as we have taken in that test, so this is your T calculated. Now we will check T at degree of freedom how much? 25 with level of significance 0.05. So the value will be somewhere around 100. Let's say with degree of freedom how much we have? 25.
1.70.
The test were two tail test. 25 two tail test with 5 degree of freedom, 5% of level of significance, 25 degree of freedom, so 2.0060. It's a 2.062. So now we can tell what the decision we will take. T calculated is less than of T table value, so we have to accept the hypothesis. Clear till here? Shall I go ahead? Third type.
Sir, in the t-test table, uh, for 2 degree of freedom means how to check means what I am seeing in the table t-table, there it is showing 1.708.0.05 degree of freedom means degree of uncertainty.
Sorry, your voice is not that much understandable. Can you write in the chat box? I'll see.
Okay.
I will explain that next part. Meanwhile, you can write. The third one is that we were having the two independent sample, but now we have the dependent sample. Like it's a paired sample. It's like a doing the testing any population. Like we want to check we have administered that polio drug to a group of people. So for that we will take we are going to check whether before the drug or after the drug what is significance. Okay, so for that type of, so we have to go t-test, like if the number of sample is less. If the number of samples are large, so you have to go for the and that is ANOVA, two-way ANOVA if the more factors are coming. Okay, so for that we have to again that we have to start with the hypothesis only. So again I will say hypothesis. So what is that? In that we will say that both whatever we have taken in the second case. So it not will be your will be mu of first population, then second population. So this is your null hypothesis. Alternative will be again that is not correct. So it will be a two tail mu x1 or so this will be the one tail. Okay, I will see that question. Have you posted it? Yeah, in the t-test table, na, it's a two-tail test. Like we are not sure whether it going to be increased. So let's say for the two-tail test, it's the 10% is there. So means one tail test it will the 5% only. It's because of symmetry only. It will come to the because we are saying this is a normally distributed. Normally distributed means you know that that is going to be a that is not going to be skewed any side. That will be evenly, like it will be that is symmetry. So two tail. Let's say you are saying. So let's say we have this one. So this is normally distributed. So when we are saying the two tails, they are going from the minus infinity to plus infinity. So means let's say 10%. So it will going to be at both sides, like 5% this one, 5% this one. But if we are specifying the what you can say one tail, maybe the right left tail or right tail. So what will happen if two tails? This is 10%. So what will be the this side will be the 5, this side will be 5. Is it correct, na?
Understood, sir. Means it will be double in case of two tail test.
Yeah. Doubt clear, na?
Yes, sir. Yes, sir.
Okay. So now we will go to the third case. Like we earlier it was the independent sample. Now we have a dependent sample. I told the example like when you have taken the sample, now you are checking before and after the effect. Like you have administered the drug for the polio, what are the before effective or either then before and after. Okay. So for that we have to first start with the hypothesis. Then degree of freedom will be again same. It will be mu is equal to n minus 1. Okay, because there will no because n1 is equal to n2 only will be there, and then n1 is equal to n2, that should be less than of 30. Okay, so in that test statistic what will come, I will write the formula for that. Okay, that the formula will be that T is equal to d bar upon s by root n, or d bar upon s into root n. D is the increment. Let's say I have done some training for weight gain training. Okay. Now before the training, my weight was somewhere around 65. After the training, just because I have done for the gain the weight, so it will become a 70. So what is the increment? So it becomes 5%. 5. So that will be your x1 minus x2. Means that will be from sample 1, and this will be from sample 2. If we talk about the standard deviation, so how it will be there? Whatever the decrement, then their mean, then upon n minus 1. Okay. Then we'll, in the third case, this was the second case, second step. The third step will be the decision. That will be the same. Okay, means t calculated is greater than t tabulated, so we have to reject the and t calculated less than the t tabulated, so accept H. We'll do one question based upon this. Let's say an IQ test was administered to 5 people before and after they were trained. The results are given below. So test whether there is any change in the IQ after training. Please do it. All formulas are there, all things are there, just do it. We'll go a bit fast because it's 7:20 already. I will write the formula, don't worry. Like a standard deviation formula. D minus t bar whole square upon n minus 1. T will be your d bar s root under. Just now please do it. Okay, we'll start. Shall I start or I'll wait for some 5 minutes? Huh? I'll wait for some 5 minutes.
In the question, the IQ, both are written as IQ before training. It will be, one should be IQ after training.
Oh, yeah, sorry, that will be after training only. Sorry.
If there is any decrease, then we have to consider minus. Like in the second candidate, the IQ is decreased. So should we
And yeah, no issue with that. Sometime it will happen.
should we consider 2 or minus 2 in this case? The
Minus,
difference?
then
Okay.
anyway, overall, if you're going to get the T, it will be the positive only. Okay. We'll just start slowly. We'll start with the hypothesis. H naught will say there is no significance difference in IQ before and after training. Okay, then alternative hypothesis will be mu1 x. Because we are not sure, that's why. So we went to the two-tail test. Is it correct till here? So we will create the data set. First one is the x1, second one is the x2, third will be the x1 minus x2, then d minus d bar, then we will calculate d minus d bar to the whole square. What is the first one? 110, 120, 123, 132, 125. Second one is 120, 118, 125, 136, 121. So what came? It came the minus 10 x minus x2. It came around 2, minus 2, minus 4, minus 4. Now we will take d minus d bar. What is the d bar will get? How much will get? Minus 10 by 5. Is it correct now? Sixty-four, 16, 0, 4, 36. If we do summation d minus d bar whole square, it will come somewhere 64, 36, it will 100, 100 plus 120. Is it correct now? Now we will calculate the statistical sample deviation. That will be S is equal to D minus this is 120, 5 minus 1, 5.477. So S came 5.477. Now we can calculate T is equal to D bar upon S. Can anyone say the T value? Minus 2, 5.477 into n equal to 5. How much? Minus point. 8165. Correct, na?
Sir, one doubt I have.
Okay. Tell me.
Sir, in my calculation, what I did is here in the table, you can see the D. D first for the first line, D is -10. Okay, and D bar is 2. So when we are doing D minus D bar, so -10 -2, it will be -12 as per my calculation. That's why my calculation is wrong. Means if we do D minus D bar, it should be -10 -2, so -12 as per my calculation.
Yeah, yeah. Sorry. -10 into 2 minus 4. It will become 144.
In that case, the D minus D bar summation will be 440 as per my calculation. 440 summation.
Okay, 144.
I'm not sure, you can check.
144 plus 16 plus 4 plus
Yeah,
56.
One,
It's coming 200. Check with the calculation. There
Okay,
may
sir.
be some
Okay,
person
okay,
mistake, but our aim should be like to get whether that one. Can you check the others, please? Check.
As per my calculation, the S value is 10.48 and the tabulated value is 4.264. So the calculation value is more than the tabulated value. So we can use it.
Let me check. It's coming 200, and we'll go with the 200.
16.
4. It will be root 50 will be 7 point.
So, as per my calculation, the table, there are some other wrong calculations. In the second line, it will be D minus D bar will be 0. 2 minus 2, 0. Second line.
This one.
Second line. No, second line.
Okay.
2, the D value is 2, and the D bar is also 2. So D minus D bar will be 0. Second line. Sir.
Okay.
Second row.
Okay, second row, huh?
The D minus D bar will be 0.
No. 2 minus 2 bar.
Yeah, D bar is 2, sir. Oh, minus 2. Okay.
Minus 2.
Okay. Okay.
Minus 10 minus 2. So it's fine. It will come 8 only.
Okay, sir. No, that was correct. The answer is minus 2.
Yeah.
Sir, your answers are matching, but
Okay, fine.
T
Still he is.
calculated is 0.81
Yeah.
minus 0.81.
Yeah, I got also confused with him. This is correct. Not this will be the 120. This will be the 120. This will be the 30. The final answer is 5.477. This will be the now become T calculated. We have T calculated how much? 0.8161. Is it?
Yes, sir.
T tabulated will go for that degree of freedom. How much is that? N minus 1. 5
4.
minus 1 is equal to 4. The 4 level of simulants will take 5%. So
1.264.
1 point. I will check. 4.604. Is it correct?
4.264.
So T calculated is less than of T tabulated. So we have to accept the Fine.
Sir, actually my doubt was there. Initially, what I did, the you subtracted from x1 x1 to x2. I subtracted from x2 to x1. Means
Ah,
I subtracted from x2 to x1.
okay.
Means like initially it was 10 for me, and the second row it was -2 for me. Like that I did. So is it okay? That's why I got confused with your table.
Either if you do both way, it should come same only. Can you check one
The
once?
result is same, sir.
Then fine. We don't have to worry too much. Now we'll go for the next type.
Sir, in previous sum, you have taken T table value according to 99%.
No, no.
Table value 4.604.
Let me see. It's 1%. Let me. It's. Let me check how much the value total test and 4.
Okay.
Okay. Yeah, it's yeah. In the question, if it is given 1%, then we can go for that. Otherwise, let me see with the question. If that is a 5% also, there is no issue with that. We can total test
It is
2.70.
we are not
Yeah,
accepting null hypothesis. Yes.
yeah. I think in the question I have to see the books from the I think in my I have made a note in I think it's missing. So both are correct only. So only we need to understand the concept that like
Okay,
if
sir.
that
Okay.
values are coming more or less, so accordingly we have to select or reject. Can we do this question in fast mode? Same or shall I go ahead with that next type? I will solve. Don't if you don't solve, I will solve in the fast mode. But the question is that we have start with the null hypothesis that H bar will be mu x1 plus mu x2 is equal to and H1 bar will be what is correct. They are saying that increase in the blood pressure is correct now. 1 till t test. Okay, so they have given number n is equal to how much 12 and we'll go make the table. Let's see if I'm able to do it here or not. D already given, like increase in already given, so we can calculate d minus d bar, then we can go for the d minus d bar whole square. Can we go now? It's 5 2 8. Can someone calculate the d bar? -1 3 0 -2 1 5 0
31 total.
6. Okay.
31 divided by 12, 2.58.
Okay. T1 31 by 12.2.58. Okay. So we'll be having 2.58 minus point, so it will become 2.48 minus 0.58, then 5.48 minus 3.58. Just check with the calculation. If I'm doing wrong, just tell me. 2.58 minus 4.58 minus 1.58 minus 2.58, no 2.42 minus 2.58, it got congested. 1.42, then last 3.42. We'll take the value to 6.15, 0.34, 30.03, 12, 12.82, 0.18, 6.66, 12, 20.98, 2.49, 6.86, 6.60, 2.02, 11.69. Can anyone tell summation of it? Came around 1 not
5.8.
105.8. Okay, so now we'll calculate the next one. Now we'll calculate the t. What is the t? D upon s into root under n. 2.58 upon s is the, we have to calculate the s also. And minus 1. Can anyone say 1 point upon 11? How much came? It came 3.1.
Yes, sir.
Total value for t 2.88. For level of significance 5%. So t table will go with 11, 0.05. It will somewhere 1.796.
Yes, sir.
So t calculated is greater than of t tabulated. Okay. So we have to
Okay, sir.
reject the negative sequences. No problem. Now we'll go with the next one. What is the fourth one? Like last type of the t-test, that is to test the significance of an observed sample correlation coefficient. Okay. So in that, what we have to assume for that, here assumption in that for null hypothesis, always like H naught is equal to population correlation coefficient mu will be the always 0. Mu is 0. So in that rho is equal to 0. When we are saying the correlation coefficient, so it's always rho. H1 is equal to, that should not be 0. Okay. If you say about the sample correlation, it will R, not gamma, R. And if you say population correlation, it will be rho. So for this test statistic will be R root under 1 minus R square into n minus 2, and degree of freedom will be n minus 2. Okay. So R is, I have told, this is the sample correlation coefficient, and n is equal to sample size. Then again the doubt will come why we have taken n minus 2. So it's a correlation coefficient. So it's more or less like this is the special case that we are going for the correlation coefficient instead of going for the difference mean or anything. Okay. So this is all about the what we can say Then after in the third case, what was that? First one was to assume that set the hypothesis. Second one was that to test a statistic. Third one is the decision. So decision you already know, so I will not explain. I will go ahead with that. Then we'll do one question. A random sample of a pair of 27 observed from a normal population gives a correlation coefficient of 0.42 if that variable in the population is uncorrelated, which we have to check whether that populations are correlated or not correlated. Variable in the population is uncorrelated. But that can check for that, and they have asked to test at 5% level of significance. But that H0 will be the, we keep 0. H1 will be the rho is equal to 1, 1 not equal to 0. Sorry. And correlation coefficient is already given 0.47. Okay. And we have already know what is that? 27. Now we can calculate the test statistic. What is that? R is equal to 1 minus R square into n minus 2. What is the R value? 0.42 upon 1 minus R 0.42 square into 27 minus 2. Can anyone tell this value? Please say this value. Uh, 0.42 square 1 minus root under 0.42 upon answer into 5 2.31. So what will take the decision? T calculated is greater than of T tabulated. So we are going to reject null hypothesis. Is it correct?
Yes, sir.
Okay, we'll go with the next test. Can anyone tell about what is the F test?
Comparison of variance.
Comparison of variance. Okay. Beforehand, can we say like distribution? What are the properties of that F test? F distribution.
Right side skewed, sir. Minimum value is 0.
The minimum value will be 0, and it going to be a maximum till infinity.
Infinity.
Yeah. And then it will be have the two parameter like one variance, two variance. It's just like always two population will be there always. Is it correct? So when we
Yes, sir.
speak about the F test, so we will be having one population and then second population. In that it will be the variance. So that's what we need to check whether any changes are there or not. Maybe if it comes to the sample, so we'll take sample 1 for this sample 2. For that sample size will be the 1 n1, this will be the n2. For this variance will be what will be there? S1 square. For this what will be there? S2 square. Okay. So what the objective of the test? I will just write it. I'll take one slide. And, So if we speak about the objective of the F test, what is that? First one, to test significance of equality between two population variance. Can we say? Second will be to test. Anyway, when we say F test, we have to think about only the variance only, but it will come in some different words. Among 3 or more means. We'll do one question based upon this. So what is the first step? Set the null hypothesis. What is that? We'll assume both the variants are same. Is it correct now? Then we'll set, okay, both alternative will be the, it is not same, so this is the two tail, and if it is greater than this one, so we'll say right tail, or will one more, this is both, will say one tail. Okay, so this is about the setting the null hypothesis. And what will the F statistic? Earlier it was T statistics, so here it will be the F statistic. F1 will be the S1 square, S2 square. Okay, or F will be the S2 square upon S1 square, means whichever is the greater variance. We'll say for degree of freedom 1, for degree of freedom 2, greater variance upon a smaller variance. Okay, so how you can calculate the S square? N minus 1, if we say S2 square, x2 minus x2 bar का whole square upon n minus 2. So degree of freedom will be the n minus 1, n1 minus 1 for 2, n2 minus 2. Is it correct? For single tail, will take F alpha degree of freedom 1, degree of freedom 2, but for two tail, F will be the alpha by 2. Okay, so this thing we need to take care. Okay, so we'll do one question based upon this, or you want to write this material will be available. You have went through the sheet, na? Like one spreadsheet will be there, that video and then content are there. Have you seen? Anyone?
Yes, sir.
The PPT and all the things I will put in that spreadsheet.
It is shared in Drive, I think. Google Drive.
Yeah. The PPT will be in the Drive folder, and the video will be on the YouTube. So both the link are available in that NPTEL course outline section. So we'll do one question based upon it. Please start. In a test given to a group of students from a two normal population, the marks obtained were as follows. Then they have asked to 5% of level of significance whether the population had the same variance or not. Can you try or shall I start? I will start. We have two more questions is there. This one and one more question will be there. Then I will just introduce to you regarding the what is the ANOVA and then how we can do. Okay.
Okay, sir.
We will first assume like both the classes having same variance. Then we'll go with the alternative hypothesis. I will say no. So this is the two-tailed. Okay. So x1 bar like 37 we have to first. We will make the table. Let's say we have a group A, they have x1 minus x bar, x1 minus x bar का whole square. Then we have the group B, x2 minus x2 bar, then x2 minus x2 bar whole square. 18, 20, 36, 36, then 50, 49, 36, 34, 49, 41, 29, 28, 26, 35, 30, 44, 46. Can anyone say x bar?
37.
37. So we will have minus 19 minus sorry, 70 minus 1 13, 12 minus 1 minus 3 12, 12, 4, it came 16, 144, 9, 1, 144, 169, 1, 289 and 99 and 361. Can anyone tell sigma x minus x1 bar and a total whole square? Somewhere around 1134. It came around this much, 34. So minus 5, minus 6, minus 8, 1, minus 5, 10, 12, 144, 100, 25, 1, 64, 36, 25, x 1, 2, sorry, it came around some 386. Okay, so now we'll calculate the S1. What is that? Upon n minus 1. S1 square we calculate. 1134 minus 9 minus 8, so it will become some 141. Okay. From here we'll calculate S2 square. Three 86 upon 6, it will become 64.33. So we have S1 square is greater than, so S2 square, so we will do one thing. So we will go for the F calculated. S1 square, S2 square, 141.75 upon 64.33, 2.2034. What one 8, 6, and then alpha by 2. I told it's because of two tailed. So you can go for the F86 2.5%. What is that? Anyone can say the value? I will show you the value. It's a 8 or 6. 8 and 6, how much? 5.60. Just say we have first one will be there, like upper one side 0.1, two sided will be the 0.2, so means 90 percentile. Okay, means 10% of level of significance. Here it's like a 5% of level of significance. So means two sided is again still 10, but the third one is that this one 5% of significance level. So means 97.5 percentile. So in that we have the 8 or 6. We'll go this one 8 will come down here and it will 6. So it is a 5.60. 5.60. Have you got it?
Sir, can you tell me once more how to check the table?
Yeah. Just say if we check about the 100 minus percentage, so this is the one common table is there. If we want to go for the 5% percentile, and for that one sided is the 5% percentile, and then two sided will be the 10%. So overall it's a what we can say 95% percentile. Okay, but if we are going for that upper one sided is the 2.5, then two sided will be the 5 percentile. In our question they have told two sided 5%, but if we divide it in the one tail two tail, so it will be 2.5% only. So effectively we have to check for the 97.5 percentile only, because we are not going for the alpha, we are going for the alpha by 2.
Okay, sir.
So it will be the 8. Then we have this link, I don't know whether sometime I'll put in the drive link. Okay, so you can check it here. Then after, so it become a value of 5.60. Okay, so F calculated is less than of F tabular, so we have to accept the null hypothesis. So this is all about what we can say F test. We'll do one more question is there. Can you do it this one? Like already S1 S2 are already there, N1 is there, so directly you have to apply the formula. Just say which one is whether that we have to accept or reject. Okay, I will start. It will be the sigma a square, or either maybe you can s1 square also you can write. S1 square h1 will be the so this is again 2 right tail test. No, it's sorry, they are asking group A is more than, so it's a right tail test. Okay, so s1 square will become 9, s2 square will become 9, so f will be the 9 upon 4, sorry, it will become 4. So how much came? 2.25. n1 is the 16, n2 is equal to 9, so degree of freedom is 15, 8. So now you this one we got if calculated 2.25, and if tabulated for 5% level signature, so if because of the one tail, so it will check for the 5% only and 15.8. So you can go to that, so you will get a value of 3.22. So decision will be, we have to accept the null hypothesis. Can we stop today? Shall we stop today? Like next class we'll see the ANOVA.
Okay, sir.
Any doubt is there till now? Is it clear now? Can someone give the feedback? Yeah, I will upload on the YouTube and then update in the that spreadsheet.
Thank you, sir.
Okay, thank you so much.
Thank you, sir.
Any comment, any doubt or anything that you can ask.
Sir, I have only one question that you have taught us that correlation of efficient. We have not been taught yet. Will it be asked in exams?
Okay, I'll check it out. Like it was t-test, I will check it out. Huh?
Correlation coefficient. Okay, just that one only.
Okay, I'll
Okay.
clarify in the next class, next session.
Sure. Thank you, sir.
Okay, thank you everyone.
Thank you, sir.